Hi ladies, welcome back, and today's talk is going to be around shift work, jet lag, children and elderly. So I want you to just bear with me on this topic because there's quite a bit to go through, but I need to explain jet lag first in order for you to then be able to understand how shift work then impinges and kind of works basically in order for you to get your head around it. So you'll have to excuse me as well because I am reading notes on this today because there's a lot and I didn't have time to put this all in the presentation. But I want to talk through a couple of tools that you can use to combat things like jet lag and offset some of the negative effects of shift work to make life easier, potentially. Well, I know there's a few of you that are obviously newer parents, and also anyone that's got adolescent children that are obviously struggling in terms of their sleep-wake cycle. So what we're talking about is basically when we look at, if we take a step back and remind you that when we're talking about sleep, is that we're talking about an endogenous, meaning a rhythm within us that we call the circadian rhythm. And for some reason my mouse isn't working. Now, the circadian rhythm is basically a rhythm of 24 hours in so many functions. And the most prominent function is feeling of waking and sleepiness. So this can happen even when they've done studies of people living in a cave. We all have this rhythm of about 24 hours. It might not be exactly 24 hours for every single person, but it's there or thereabouts. And basically what happens is your body goes from a low to a high, back down to a low temperature again, and it takes 24 hours for that to repeat. Not 18, not 264, or more than any of that, and it's always within that 24-hour kind of period. So you have a rhythm in sleepiness and wakefulness that correlates with when we tend to lend being sleepy as our temperature is falling and getting lower. We tend to then be more awake when waking when our temperature is starting to increase, and this is biological fact. It's down to our DNA, and we have genes, and every one of those single cells ensures that every cell is on this 24-hour rhythm, or obviously as near as damn it. So what basically happens is that we have a clock over the roof of our mouth, and it's called the suprachiasmatic nucleus. Now you don't need to remember that, but this is basically generating our 24-hour rhythm that we have. And it's basically trained to match external light and our dark cycle. So, 24 hours, Earth spins, it's fixed 24 hours. So our cells and organs, our wakefulness, our temperature, also our metabolism and our immune system, even our mood, everything is basically tethered to outside light and dark cycles. So even if we were living in a perfect way where we would wake up in the morning and we had the view of sunlight that crosses our eyes, and then by the evening we catch a little sunlight, and then at night we're in complete darkness, this will be more or less perfectly matched to the external ambient light and dark cycle. But very few of us do this because of things called artificial lights. Now, there are those people that might say, well, I'm a bit of a night owl or I'm a morning lark. However, human beings are basically a diurnal species. So basically we are constructed to being awake in the daytime and asleep at nighttime. That is how human beings are programmed to be. And many studies have shown that when we deviate too far from our diurnal schedule, we try and become nocturnal. We can pull it off, but it does have serious health effects, both physically and mentally in terms of the structure. And there's quite valid data around depression, amnesia and dementia, not to mention everything else that happens with not sleeping too well. So in terms of a perfect schedule, and I want to lighten this to jet lag, because I know that we're going to say jet lag thinking that travel, but necessarily we are always in a state of jet lag, even as we are right now. So what jet lag really represents and how much to push back on jet lag and shift your clock faster and escape some of the severe bad things that can happen with jet lag, including just feeling miserable. So we need to kind of think about what that perfect schedule would be to help that. So what is the perfect day? What does that circadian sleep cycleness look like? I'm going to summarize basically how that looks. So in essence, you basically want to get as much daylight, which is primarily from sunlight, being actually physically outside, as much light into your eyes during each 24-hour cycle when you are awake. You want to get as little light into your eyes in the times when you want to be falling asleep or feeling drowsy. So when we think about light itself, what is possibly something that's too bright? Well, if it's painful to look at and you need to blink or close your eyes in order to bear that daylight, please do not look at very bright lights. So it's painful, it'll damage your eyes. However, if you do get up in the morning, it's still dark out and you want to be awake, you would be wise to turn on artificial lights in the house. In particular, overhead lights, because of the angle that it comes into the retina at. Optimally, this will then trigger the neurons, basically within the retina, like I've just mentioned, and it'll activate your circadian clock. Then, when the sun does come out, even if the sun's overcast, regardless of where you live, unless you live in a cave, then you're still going to get this amount of sunlight that you actually need to activate these cells. Maybe if you were like in Scandinavia and you're always in darkness, then yeah, you might want to try and seek out some kind of method of artificial light, which we'll talk about later anyway. So in terms of what we actually need is, we class it as a number in lux. So like you'd obviously measure grams, measure scale weight in kilograms maybe. So light intensity is measured in lux, L-U-X. And we need at least 100,000 of that per day, preferably before 9 or 10 a.m. per day. But before 9 a.m, and that's assuming that you're waking up sometime between 5 and 8 a.m. in the morning. So to get 100,000 lux, you don't want to be repeatedly staring at something that's super, super bright that's going to hurt your eyes. The mechanism of the circadian clock setting is very important. And setting this involves the neurons in your eyes that send basically electrical signals to the clock above your mouth that basically that system sums, meaning adds photons to it. And it's a very slow system. So let's say that I wake up and I look at my computer screen briefly, or my phone screen. That's probably 500 to 1,000 lux. So if I was to look at that then for a full minute, I would get that photon energy transferred into electrical energy of neurons, and it would be communicated then to this little clock above my mouth. However, the signal that it's morning will not have registered with the circadian clock unless I looked at it for at least 100 minutes or more, so that equals 100,000 lux. So if you were to wake up at 8 o'clock in the morning, you're not going to get enough light from artificial light before you reach what we class as a circadian dead zone. And to do this, the opportunity is before 9 o'clock in the morning, maybe pushing 10 o'clock in the morning. So you do have to go outside to do this in order to get this amount of lux. If you wanted, there is actually a light meter that you can get, and it's on your phone actually. I think it's called Lux. Or is it just called Light Meter? Yeah, it's called Light Meter. And you can basically go around your iPhone or whatever phone you've got, and you can actually stare that at a screen or a kind of light around the house, and it'll tell you how many lux is actually coming out of that screen, whether it's your phone screen, computer screen, ring light, it will tell you. But going outside, even on a cloudy day, could be like 7,000 to 10,000 lux. So it's remarkable how bright it is, meaning that so much photon energy is actually coming through those clouds, even though we think there isn't. So trying to get this 100,000 before 9 a.m. would literally potentially only take you 10 minutes. If we do consider Northern England, it's not sometimes bright enough in the winter. You can possibly resort to using artificial light. So like I've got my ring light here. You can use that. It does have blue light in it to activate these cells. Light has to be captured in some way before you enter the circadian dead zone, which is basically the middle of the day where the sun's at the height, where like for me, I cannot stare. Like I get really squinty eyes. My eyes will stream if I try and stare or be out in the sun when it's just too bright, full stop. My eyes can't take it. We need a lot of photon energy during the day to wake up our system and set our circadian clock. And this prepares them for a good night's sleep, which is usually like 14 to 16 hours after obviously we've been exposed. It takes little photon energy to reset and shift our clock after 8 p.m. So if you are seeing bright lights after that time, it doesn't need much of it to then have a knock-on effect on your sleep. So if you can safely avoid bright light, even not so bright light between the hours of like 10, 11 and 4 a.m., like that 11 till 4 p.m. to a.m. is essential in terms of trying to not see any bright light in that time. So if you see afternoon light, if you're going to adjust down the sensitivity of your eyes so that you have a little bit more wiggle room and a little more leeway to view lights from screens and overhead lights, even late at night, without disrupting your circadian clock, it's kind of a double-edged sword where you need a lot early in the day and you need to avoid bright lights later on in the day. And there's been some studies done on this. So in terms of some camping studies that have been done trying to reset circadian clocks, and they've shown that 2 days of waking up with the sun and avoiding light at night, they actually took some graduates on a student camping spree, and the experiment basically was part of trying to reset their melatonin and cortisol rhythms for these people, so that they've obviously like drifted off quite far in terms of their natural clocks. And you can also shift your clock to reinforce using things like exercise. So more or less at the same time every day, and also eating at a similar time every day can also help this clock. In the evening, you see the evening light and you want to get that so that the light to adjust down your retinal sensitivity can be afforded to be a bit of a buffer. So that late at night, if you do happen to look at screens or go into the bathroom in the middle of the night, light isn't going to shift your clock too much. Because we're going to remember it takes about 1,000 to 1,500 lux of light energy to shift your clock in the middle of the night. But if they're bright, then that's going to do it. So you need to be really careful. So let's move now onto jet lag, so we kind of get some understanding of how this can knock on to then shift work, because obviously they both are basically a shift in the clock. And this ability to shift the clock with light and temperature and exercise and food are vitally important to get onto like a new local time schedule. And there's so much about jet lag today that it's just amazing that you don't actually have to travel to get jet lag. Many people are jet lagged because you're looking at your phone in the middle of the night after these, late night times. And you're jet lagged because you're waking up at different times of day, because you're maybe like your exercise regime's chaotic or you're on shift. So there's a tremendous amount of variability out there with this person to person, but this is kind of like we're talking about an optimal thing here. So many people will travel to a new location and they'll possibly feel great on that first day or that first night, and then they'll possibly like have a bit of a crash and they have trouble sleeping, or when they travel back, they have a really bad time trying to get back into a normal schedule. And some of this varies with age, some of it can be down to genetics. There's no simple pill or anything that can take away getting rid of this jet lag. It doesn't work that way. But there are some simple things that you can do to kind of get this back on track. And fundamentally, there are quality peer-reviewed studies that are out there showing that jet lag will shorten your life. It will kill you earlier. So yeah, it kind of means you're going to die earlier. Not to obviously put a burden on that. And if you've ever really been jet lagged or fallen asleep, it doesn't even have to be in the middle of the day to be woken up. You might just not know where you are, basically. That's because time and space are really linked in the brain, and it wasn't designed to basically be transported 4 or 6 hours ahead into a new time zone. It wasn't just our brain, but the biological mechanisms that actually govern circadian timing are designed to be shifted by only a couple of hours, not necessarily like whole jumps in time zones. So it can really mess yourself up. Interestingly, if we travel westward on the globe, it's easier than travelling eastward. So travelling east takes more time and years off your life than travelling west. And going like 2 time zones over is far less detrimental to your biology and psychology than say like an 8 or a 9-hour shift, obviously jump forward. And this idea basically can have a huge impact on our lives. We need to bear this in mind. But we need to ask ourselves why that is. So I might have mentioned before about our autonomic nervous system, and this is a set of neurons basically that's in our spinal cord and within our body and our brain that regulate wakefulness and our sleepiness. And it turns out that human beings are probably, and probably most species, are better able to activate and stay alert than they are to shut down their nervous system and go into sleep on demand. So if you think about it, when you really have to push to stay awake, you can do it and you do just stay up later. However, trying to fall asleep earlier is very much harder. And that's why travelling east has a number of different features associated with it. That's because when you're travelling east, you're going to bed earlier than what you know. So say like if we were to go from here to maybe, I don't know, Dubai, would that be far enough? I've got to get to bed possibly like 3 hours earlier and wake up 3 hours earlier, which is much harder than coming back and obviously just staying up a few more hours. So this probably has its roots in evolutionary adaptation, where under certain conditions we need to be able to suddenly gather up or go and forage for food or fight off like obviously different things that might come up animal wise, and be able to push ourselves to release adrenaline and epinephrine, which is basically another word for adrenaline, in order for us to stay awake. Being able to slow down and deliberately fall asleep is actually much harder to do. There's so much asymmetry to our autonomic nervous system that plays out in the asymmetry of jet lag. So east is harder because going to sleep earlier is harder if you're trying to do that on demand. And many people have turned to using things like melatonin, which is a supplement, in order to actually bring on the onset of sleepiness. But it can be detrimental to some hormone systems, so I wouldn't necessarily recommend this. Because basically you can be suppressing a hormone pathway that might involve things like luteinizing hormone in testosterone with men and also estrogen in women. And also involves a very interesting peptide called kisspeptin. Very cute. So when we actually then think, instead of going east and west, what about going north or south? So if I'm going obviously from here to maybe like Iceland or here down to Africa or something, you're just going north or south, right? You're not going in either direction. So you're not really moving into a different time zone. You're not shifting. So this will be more like just travel fatigue really than jet lag. And jet lag has 2 elements, travel fatigue and time zone jet lag. Time zone jet lag is simply the inability of local sunlight and local darkness to match your internal rhythm. And this is the endogenous rhythm that you've already got inside you. Most people do experience jet lag as they get older. It usually gets worse. Early in life, patterns and melatonin release are generally pretty stable and flat and have a very high actually in children. So it's one of the reasons why they wouldn't undergo puberty if they were to take like melatonin supplements. It becomes cyclical then during puberty. And once it then comes on, it then means that once every 24 hours and turns off every 24 hours. So it basically becomes more like a cycle like the rest of us. Then as we get older, the cycles become more disrupted and we become more vulnerable to even the smallest change in schedule. So this can even be meal times. So jet lag gets worse with age. Doing less exercise as well, digestion also gets worse as part of that. So things that correlate with being older, like people who are willing to have regular exercise routines that can exercise and shift their circadian clock, is definitely recommended, especially as you get older. So all this about, I can't lose weight when I get older, I can't do this when I get older. If you have something that's steady away and a good exercise routine, if and when you can travel again, or even like undergoing more shift work patterns, having a good routine will definitely suffice and help with this. So if you do have a regular exercise routine, it's going to be easier to make the shift in your circadian clock for the sake of something, say, like jet lag. It's actually like a knob that you can turn and you can let it kind of leverage in terms of shifting your clock a little bit. So changing your internal rhythm is actually quite easy. Most important things to know about your body and your brain is something called temperature minimum. This is key to resetting both jet lag and also working on shift work, so your temperature minimum. So most of you might know like your weight, you might know like your dress size, your blood pressure. Some of you might even know your BMI if you obviously care for that. And everyone should know their temperature minimum, and I'm going to go through how to do this. And it's basically, it doesn't need a thermometer to measure, although you could measure it if you wanted to. Your temperature minimum is the point in every 24-hour cycle when your temperature is the lowest. It tends to fall 90 minutes to 2 hours before your average waking time. So say like if I regularly get up at usually around 6 o'clock-ish, my temperature minimum would be around like 4 to 4:30. So let's say you're not travelling and your typical wake-up time is, say, 5:30, your temperature minimum time will probably be around 3:30 to 4. Then what will happen is your temperature will then start to rise from that time of waking. So that temperature minimum time, 2 hours or 90 minutes before, it'll slowly start to have a gradual incline to then obviously when you wake and as you carry on waking. And then it'll rise and peak around the afternoon. So after that point, it will then slowly start to decline as you approach to nighttime. So there are things that will disrupt this temperature pattern, such as saunas, cold baths, intense exercise. Meals also tend to have a thermogenic effect that increases temperature, but these are more like slight minor blips. But the overall cycle of 24 hours of temperature has this pattern routinely. Temperature will vary from person to person, and it's determined by taking the last 3 to 5 wake-up times. So let's say if you woke up at 7 a.m, 8 a.m, and 3 a.m, it does happen for people. You want to take those together and take the average. So add them up and divide by the number of days. Obviously, that's your average. If you're one of these people that wakes up at 3 and then goes back to sleep until, say, like 10 a.m, your wake-up time is then 10 a.m. That's your proper wake-up time. So take that wake-up time, you then get an average or sort of your typical temperature minimum kind of time. And this becomes your absolute reference point then for shifting your circadian clock. So whether or not you're going through jet lag or shift work. If you expose your eyes to bright light in the 4 hours, maybe 5 or 6 at a push, but in the 4 hours after your temperature minimum, your circadian clock will shift. So that will lend itself and tend to, if you get up earlier and you'll go to sleep earlier in the subsequent days, and that's what we call phase advance. If you view bright light in 4 to 6 hours before your temperature minimum, you'll tend to phase delay your clock. So you'll wake up later and go to sleep later. So I tend to wake up around 6 a.m, maybe sometimes 6:30. Temperature minimum is probably somewhere around like 4:30 a.m. If I wake up at 4:30 a.m. and if I were to view bright light at, say, 4:35, I'm going to advance my clock and I'm going to want to go to bed earlier the subsequent night and wake up early the subsequent morning after that. And as I shift my wake-up time, my temperature minimum shifts to, because each time we shift our wake-up time, our temperature minimum also shifts with it. So say if I did start getting up at then 4:30 a.m, my temperature minimum time is then going to be between 2 to 3:30 a.m. So each time we shift our wake-up time or our temperature minimum will shift, assuming that wake-up time shifts more than up to like 30 minutes to an hour. So if I were to view bright light in the 4 to 6 hours before 4:30 a.m, guess what? The next night I'm going to want to stay up later. I'm going to want to wake up later the subsequent morning, and your temperature minimum is a reference point, not a temperature reading. So understand that in the 4 hours or so, just after that time viewing light, this will advance your clock, making you want to get up earlier. And the 4 hours before your temperature minimum viewing light will make you want to stay up later. So when we actually think about something like insomnia, the definition of insomnia is when you're experiencing excessive sleepiness during the day, and sleepiness and fatigue are different. Fatigue is like physical exhaustion, sleepiness is falling asleep, and like falling asleep at your desk or during like lectures or during work meetings. Sleepiness during the daytime, usually it's around your temperature peak and only lasts around 90 minutes or so, and it is a sign of insomnia. But it is a sign of lack of sleep, and I want to be very clear that if you know your temperature minimum, you can shift your clock using light. You can also shift your clock by engaging in exercise in the 4 hours after your temperature minimum time as well to wake. So you can wake then on earlier on subsequent nights and stay awake, go to bed earlier subsequent nights, and then if you exercise before your temperature minimum and then 4 hours before, you're going to delay your clock as well. So it's the same. Seeing light 4 hours after your temperature minimum will obviously make you go to bed earlier, wake up earlier the next day. And seeing light in the time before your temperature minimum is going to have a knock-on effect in a detrimental way to making you want to stay up later and also go to sleep later. So right before waking up, when the temperature rises, you can now start to shift that temperature. So according to your travel needs, here's one way in which you might do that. So let's say I'm going from here, let's say here to Dubai maybe. And they are, mind you, they're only 4 hours ahead. So if we went somewhere more like Japan, is that further? Let's say Japan, just for now. Let's work around like the 8 to 9 hours ahead somewhere, just to kind of give you a better idea. So I would want to determine my temperature minimum, which for me is around like 4:30 a.m, maybe 5 a.m, depending on what day I wake up. And I would want to start getting up around 5:30 a.m. and start getting some bright light exposure, presumably from artificial light, because the sun's possibly not going to be up at that time. Even exercising as well, maybe before eating a meal within that 4 hour block of being up at that time. At that time, if it's in your practice and you want to start doing that, you can then do that like 2 to 3 days before you actually travel to that new time zone, basically. So it's like a 2 to 3 day priming sequence that you'll do before you know you're going to travel somewhere of like a decent amount of hours ahead. Once you then land in that point, or wherever you obviously flying to, chances are viewing the sunrise or sunset is not going to allow you to actually shift your clock at that point. And we need to also remember if we are traveling actually east or if we're traveling west at this point. So if I'm trying to advance my clock or delay my clock, basically. So remember, viewing light, having exercise and eating in the 4 to 6 hours before your temperature minimum will delay your clock. Eating and viewing sunlight and exercising, you don't have to do all three, but a good combination of those 4 to 6 hours after your temperature minimum will advance your clock. So once you then arrive in the new location that you're at, you have to keep track of what your temperature minimum was back at home and how it's being shifted during your trip. So you can actually go and look at and use your clocks, your world clocks on an iPhone or obviously whichever Android you've got, and keep track of what the time is back home, and then you can easily shift your clock going forward. We need to remember that we do have this circadian dead zone from around like 10 a.m. all the way to 6 hours before your temperature minimum starts. You're not going to shift your clock. Nothing that you will do in terms of viewing light in that time, even feeding behaviours will shift your clock after that time. Ideally, you want to start eating on the local meal schedule, and this will just help enhance your alertness basically with the local time zone. It might be that you feel like you've got to perhaps force yourself to eat. You can possibly skip that meal, but what you don't want to do is stay on your home meal schedule. So waking up in the middle of the night and eating that's gonna really throw things out of whack, because a lot of the clocks in the periphery, like if we think of like the liver or any kind of peripheral system, all the organs send these messages back to your brain, and then the brain is getting really conflicted and confused. So our temperature minimum is like our anchor point for shifting your clock the best. So let's talk about travelling westward now. So there tends to be the challenge there, so how you can actually stay up late enough. And some people are able to do this because, as I mentioned earlier, the autonomic nervous system is asymmetrically wired, so that it's much easier to stay up later than it would be to naturally go to sleep earlier. So say like when you land and you're going more westward, say it's 4 p.m. and you feel like you're just absolutely dying, you're really going to struggle and want to go to sleep. That's where the use of things like caffeine and exercise and sunlight can help shift you, right, if you're obviously then already in your temperature, after your temperature peak, so obviously mid-afternoon, then viewing sunlight around 6 p.m. or 8 p.m. or using artificial light. If there isn't sunlight, this will obviously help you to do that with artificial light. So there's going to be then a delay in your clock and you're going to be able to stay up later. The worst thing that you can actually do is take a nap that was maybe intended to last like 20 minutes, and you would then like completely sleep through for a good couple of hours. So you can have obviously like little mini naps, but anything that goes over the 90-minute ultradian cycle that I've mentioned before, that would be detrimental. So provided that we don't have excessive amounts of stimulants like caffeine, in coffee or tea, that can really help you push past that afternoon barrier and get more sleep. More like on like the local schedule and eating schedule is going to work best. In terms of using melatonin, and I mentioned this earlier, to induce sleepiness, it will help you possibly fall asleep easier, but it will not help you stay asleep. And I know that generally in the UK, decent melatonin is actually quite hard to get hold of anyway. So it does induce sleepiness. During development, it's also responsible of the timing of the secretion of certain hormones that are vitally important for puberty. And I know that most of us have already been through puberty, but it's something to bear in mind for children. And melatonin itself perhaps doesn't control the onset of puberty, not directly, but indirectly, melatonin will inhibit something called kinetic tropin, and release the hormone that's released from your hypothalamus. So roughly, again, above the roof of your mouth, your brain, gonadotropin releasing hormone is really interesting because it stimulates the release of another hormone called luteinizing hormone, which in females is estrogen, and guys, it's obviously testosterone. And melatonin is inhibitory to this gonadotropin releasing hormone basically, and therefore there's an inhibition to this luteinizing hormone that basically is an inhibitor until we're onto your testosterone or estrogen. So supplementing with melatonin, you've got to be careful because the concentrations that are actually in much of the commercial supplements that are out there can be anywhere between like 85 to 400% of what's actually listed in that bottle, which is why you've got to be so careful. And it is widely used for inducing sleepiness, but if you want to fall asleep in the new location when you've arrived, and you can't fall asleep, then melatonin could help, but it doesn't help you stay asleep. Plus, ultimately, using things more like light exposure, which is obviously free, it's accessible, and using information like our temperature minimum, have much bigger safety margins that don't have other endocrine effects, because obviously we want to avoid that. So melatonin is not going to be your best solution. So the best solution is to use light, knowing your temperature minimum, and exercising either side of that temperature minimum, depending on what you're trying to do with your trip, if you're trying to phase advance or phase delay. So understand that your temperature minimum is and how it represents an important landmark either side, which you can use light and temperature and exercise to shift your clock. And just to remind you a little bit about temperature, if you want to shift your clock, typically you would do that by taking a hot shower, and then this will have a cooling effect after the hot shower. And if you were to get into a cold shower or have an ice bath, if you have access to one, afterwards there's going to be a thermogenic effect on your body to increase your temperature. So if you think about your natural rhythm back home when everything's stable, you have a low point in your temperature minimum, and then you have a peak. And think about when you're doing this, if you want a hot or a cold shower in that rhythm, you're then able to understand how you can then shift your rhythm to that temperature rhythm. And it's the one that's going to move. Say, give an example, if you wake up in the morning and let's say 6 o'clock in the morning, I know my temperature's then rising, I've passed my temperature minimum. If I were then to get in a hot shower, that would then lower my body temperature when I got out. This is not normally what's happening first thing in the morning, and therefore my clock would very likely get phase delayed. So it's going to delay my increase in temperature, whereas if I got in a cold shower, something that I don't personally like to do, but I do sometimes recommend it to people, then also perhaps an ice bath for light recovery, that's going to have a rebound increase in body temperature, and it's going to phase advance my clock. So that peak in the afternoon is going to come around a little bit earlier, and my temperature is going to decrease a little bit earlier to make me fall asleep. I'm going to want to go to bed earlier that night. So you can then start to play these games with timings in hot and cold, even like hot and cold meals, when you do and don't eat, and light exposure, whether or not you view light or you don't. So figuring out your temperature minimum and your temperature peak, you can use these parameters to then give you some flexibility. It can give you really good confidence and flexibility to be able to shift your body rhythms however you want, and when things get out of whack, you can kind of tuck them back into place, basically. If you are, say, going on a short trip, so 48 hours or less, try and stay on your home schedule. And for a lot of people, that's going to be tough. It may require like rescheduling meetings to be a bit different according to your home schedule. But if you can somehow manage that, the best thing is to try and stay on your home schedule, and your clock's then not going to shift more than a couple of hours, even if you do everything correctly in one day. If you stay 48 hours and then you start to shift a little bit, say like 72, that's when you start running into trouble. So the transit time is more important. I would say that if there's like 3 days or less, try and stay on your home schedule as much as you can. And then if necessary, traveling with some kind of like bright light pad that you can get to just plug in. So travel with something like that is going to be you're able to do in your hotel room, so to wake up when you like. Some people use like nightshades, like the eye covers that help to basically keep light out as well, so they can be really useful when you're on a plane or in a hotel where it may be still sunny outside. You might not have like decent blocking curtains. So you can use light and dark, and you can travel with your light and dark devices as well, so you can actually stay on your home schedule and get the most of your light when it would be your normal wake-up time back home. And it's kind of nice that when you know your circadian dead zone back home is generally around, for like most people, between like 10 a.m. to 3 p.m, basically the rising phase of your temperature, then you can also feel free to be outside without having to wear like sunglasses, so you don't have to worry about light exposure. If you know that your window before your temperature minimum is that 4 to 6 hour window, that's the time, if you're viewing a lot of light in your new location, you are going to shift your clock pretty considerably. And when you come home, you'll then have a pretty terrible time. there is actually a phenomenon called ICU psychosis, where people that are in intensive care, because they're in hospital, they kind of lose their mind a bit and become a bit psychotic with hallucinations. And it's because they have this altered circadian rhythm cycle. Because they're exposed to these lights and these sounds of people coming in and checking in all the time, they then leave hospital. In some cases, there have been experiments where people have been placed near a window where they can actually then get some natural light, and the symptoms then disappear, presuming that they obviously weren't psychotic beforehand. So it's pretty impressive the impact that light can do to the psyche and to the body. And then when we think about this, then moving into shift work. So shift work's been becoming increasingly common. Many of us are shift working even when we don't have to, because we work in the middle of the night. Even when we're on computers at odd days, sleeping during the day. A lot of people then who are under sheltering places and stuff, like kids that adjust school schedules. Here's the deal with shift work. You want to try and be on the same schedule for at least 14 days straight, including your weekends. And non-shift workers, to the importance of not getting too far off track on weekend. So a lot of people, so even if you're not a shift worker and sleeping in on a Sunday, this isn't a good idea. The most important thing about shift work is to stay consistent with your schedule. What a lot of people generally trying to do now, like a swing shift where they'll do 4 days on one shift and then 4 days on another, but it's actually extremely detrimental to a number of health parameters. It also gets the cortisol released from the adrenals completely out of whack. They're then like these random cortisol spikes you'll have at various hours of the day, and it messes up learning, and it really disrupts with your dopamine system and your well-being, and it is actually a serious problem. So I know this isn't going to be possible for everybody, but negotiating with your employer to actually stay on the same shift for 2 weeks at a time can be immensely beneficial and help you actually offset the negative effects of shift work. But I know that some people won't have that level of control. So let's talk about a shift where you might start at, say, 4 p.m. and you end at 2 a.m. So ideally, you want to view as much light as possible and as safely as possible when you need to be alert. So that would mean from 4 p.m. to 2 a.m. That's naturally when you want to sleep. So using light as a correlate of alertness and using darkness as a correlate of sleepiness is see as much light safely during the day, the phase of your day when you want to be awake, and see as little light as possible, as safely as possible, in order for you to function during the daytime when you want to be asleep. So if you're finishing out at around 2 a.m, that's when you want to avoid bright light exposure. So you'd want to go home, really you want to go avoid watching TV. Obviously for those people that use TVs to fall asleep, in that case, and even if you did, it'd be trying to dim those lights as much as possible, or using something like blue blockers. So let's say you go to sleep, and you get home after this 4 to 2 a.m. shift. Maybe you eat something, you then go to sleep, and you wake up, it's noon or say 1 p.m. in the afternoon. Should you get light in your eyes at that chance? Well, first assumption, based on what I've said previously in this, might be that you'll be in your circadian dead zone at that point, because it's obviously noon or 1 p.m. But technically, you're not in your circadian dead zone, because you're somebody that goes to sleep early in the morning at 2 a.m. So it's not like the circadian dead zone is a strict time of day. It's an internal biological clock, and that will be dependent on you. This is why you need to know your temperature minimum. You need to know whether or not your temperature is increasing or decreasing. And now we can make the whole thing even simpler and just say, if your temperature is decreasing, avoid light. If your temperature is increasing, go and get light. So the shift worker who works from 4 p.m. till 2 a.m. has a temperature rhythm that's very different to, say, someone like mine, where I work daytimes, and I'm waking around 5, 6 a.m. And I go to sleep usually around, like, say, maybe 10 p.m. So yes, we both have a 24-hour-ish circadian cycle, except mine is more aligned to the rise and setting of the sun. And all you need to know is that you need to find out your internal temperature minimum rhythm. So let's go on to shift workers that are really nocturnal, so completely flipped. You want to stay on that external schedule now, and I know that's going to be hard on families and social life of kinds, but the person who is, say, working from, say, like 8 p.m, like some down to sunrise, this raises a question whether or not they should be looking at sunrise, and should they be watching the sunset, waking up with sunset, going to sleep at sunrise. So basically the opposite way around. What happens, it actually is just going to invert the sunrise and sunset when they're waking up in the morning. If they look at it like this, if they get some sunlight in their eyes, they look at the sun and get some bright light from device or overhead lights in their apartment or at home, then that's going to tend to wake them up, even if it's in the evening. So basically, the evening sun, the sun is setting and they're looking at that sun setting, that's their morning sun. And it will wake them up for their night shift, so the temperature then will start to rise. And then towards the morning, when they're closing out their shift and going home, the sun rising will work well to then kind of set the clock to then start to fall asleep. So the temperature for that person, they've been up for a while, temperature's falling, not rising like it would be for me because of the opposite way around, but because I'm not diurnal, I'm waking during the day, and for that person, that temperature is falling, so they might view light while temperature's falling, and it's going to phase delay them. It's going to make them harder to get to sleep the following night. So what you'd say to that person is that watching the setting sun will help them wake up because they're going onto a night shift, but you could probably have sunglasses on or avoid viewing bright light before they go to sleep. So not directly looking at any bright light as they come off shift, where ideal to try and wear some sunglasses. They're basically on an inverted time scale to that person that's more diurnal, obviously on a normal sleep and wake cycle. So once we understand our temperature minimum, it's something that you can totally own and that you can really use as a key landmark for shifting your clock. And I don't want it to be more of a neurotic thing attached to a schedule, because then they obviously can knock onto some like sleep anxiety where people actually have trouble falling asleep and staying asleep. So I wanted to spend a moment on that and just go back to a theme that I've mentioned before, using tools that are non-sleep deep rest, so NSDR protocols, which would be more like your sleep hypnosis, meditation and yoga. There is something on reveriehealth.com, and this is a free sleep hypnosis that will help for anxiety. And non-sleep deep breath protocols as well, so on things called like Yoga Nidra. So if you Google Yoga Nidra, it will give you some kind of protocols there to go through. You need to teach your brain and your nervous system how to turn off your thoughts and go to sleep. And ideally, you want to do that without medication, because there's a real, unless there's a real need to do that through behavioural protocols and obviously gone through your doctor, because they actually involve then the body to shift the mind and not trying to just turn off your thoughts in the middle of the night. There are going to be periods of life where things are more stressful and people are concerned and you'll have some struggle. So getting and staying asleep, and there's really, has to do with some kind of levels of anxiety there, is that these NSDR protocols are also, they are going to be a massive help with this. There are a lot of people that can use these during the night as well. If they wake and you want to go back to sleep, you can then teach your nervous system how to calm down, and also do them in the first thing in the morning if you feel like you've not got enough sleep. So do them whenever you have the opportunity to, because they can be really helpful and help you to learn how to turn on the parasympathetic branch of your autonomic nervous system. Meditation of certain kinds does involve focus, alertness, and there are slightly different meditations that involve like a lack of focus and a lack of attention, to say like more internal states. So next I want to go and speak about children and the elderly. So humans, we all have different skin tones, and genetically, because of the amount of melanin in our skin, so depending on our genetic background, and of course sunlight will increase the amount of melanin in our skin. Regardless, this is a suntan, sunburning, etc., bronzing, whatever the whole system is wired, so that the shifts in skin colour and shifts in these cells within the eye and the melatonin are actually very closely linked. In the cells of the eye, there's actually something that connects basically to the rest of our brain called melanopsin, and melanopsin is the opposite of like a pigment, so basically it absorbs light, and it's the opposite that converts light into these electrical signals that then set our circadian clock. And this is then the relationship between cells in our eyes and the pigment cells that we have in our skin. So from dopamine, this can trigger increases in testosterone in males and estrogen in females. And of course, there's testosterone and estrogen in both sexes. So we have to think of this pathway where there's light, increases melanin, dopamine, and reproduction on the one hand, and a lack of melatonin decreases the darkness of skin, less melanin and in the skin. And we need to consider that we don't actually radically change our skin colour. So depending on how much light exposure we have, a simple way to put this is that when days are long, there's more dopamine and we feel really good, and there's a lot more generally like breeding type behaviour, and then when days are short, there's a lot less dopamine and a lot less breeding kind of behaviours because the pathways are highly conserved within that time. Now, what's interesting is that we've moved to a modern society where much of our waking day is looking at screens, which is fine because we're getting a lot of light that way, but not as much actual sunlight, and also we're getting this at night. We're getting a lot of light from screens, and what's happened, these pathways in melanin in the skin turnover cells of dopamine, it becomes basically completely disrupted. The relationship to dopamine and melanin in the skin and the feel-good feelings of it, of getting light also on our skin provides, provided that you're not getting burnt and you're not excessively having UV exposure, those are not just coincidences. These are hardwired biological mechanisms that exist in everybody, regardless of how light or dark your skin is to begin with. There's also another point which is important, which is that the dopamine system, which is our feel-good molecule, is very closely related to testosterone and estrogen and reproductive cycles. And remember that melatonin inhibits gonadotropin releasing hormone and luteinizing hormone, and the release and the production of these hormones, and melatonin is the effector that's the hormone of darkness. But how does this all relate? So basically there's animals that can change their fur colour depending on their levels of stress or these hormones that they go through in the daylight and the kind of the seasonal changes that we go through. And I'm not saying that we're like hamsters, but what this then leads on to is that if you've ever noticed that when you get really stressed, there's actually an increase in the nerve fibres that release adrenaline to the hair follicle. And that activates a peroxide group in the hair follicle that actually cause the hair to go grey or white. So actually, stress does make your hair grey or white. And aging obviously will do that too. The cells in your eye are a lot like skin cells, and if we look at something like there's certain types of frogs that or other animals that completely shift their colour, and they can sometimes actually fully metamorphosize into a completely different sex. And I just realised I've gone off a bit of a tangent. Science, I'm sorry. So let's go back to new parents and babies. So melatonin is not cyclic. It's not cycling in babies, it's phasic. So it's being released pretty constantly as babies are. And they obviously are smaller than adults too. So those concentrations of melatonin are very high as a baby grows, and those concentrations per unit of volume are going to go down. Babies are not born with a typical sleep-wake cycle. They also have much more sensitive optics in the eye. So you don't want to completely avoid sunlight, but their eyes are very sensitive and the optics in their eyes aren't quite developed. So much so that when you know that you look at a newborn baby, they kind of look at you like in that kind of glassy-eyed kind of look. they're actually kind of looking through you, even as a young child. A lot of people, they're seeing you in the way that you're seeing them, but their eyes are so poor that you're just basically a cloudy image to them. They're not seeing your fine details, and that will come obviously as the optics get better. They will see you with more and more clarity, but a lot of that is the clearing basically of the lens. And some of the other aqueous features that newborn babies have, they just don't see very well, but they also don't have great ways of adjusting to bright lights. So babies have a natural aversion to bright light, and you really want to try avoid using sunlight or really bright light in the same way that you would for an adult, so on a young baby and child. As children do get older, however, melatonin does start to become more cyclic, obviously like we then move to. And it cycles through their body along with the temperature rhythms, and they all start to fall into place into a more regular cycle, not quite 24 hours, but more towards these more ultradian cycles, these 90-minute cycles that I've mentioned. Babies are going through a cycle of body temperature and some other hormonal features. So a lot is changing in their system. So what to do if a child isn't sleeping? You can use phases of darkness and phases of light, but they're going to have to be shortened in order to try and encourage sleep when you want that child to sleep. It's not that they're just going to fall asleep into like what an adult regime is going to be. Have a temperature minimum and a temperature maximum, and their temperature minimum and maximums are fluctuating more quickly, and it varies tremendously. There are a couple of things that seem to help, which is getting an overall environment into a 24-hour schedule so that the room's slightly colder. Obviously, babies like to be nice and slightly cooler when you want them to be asleep, and slightly warmer for times when you want them to be awake, because babies tend to run pretty hot anyway. And you want to be very careful about avoiding all extremes of hot and cold. So if they're going through these 90-minute cycles, you're going to have to adjust those 90-minute cycles as well. A couple of tools that can help. The first one is going to be trying to understand the relationship between calm and deep sleep. So the automatic nervous system can put us into states of panic, where that's been like this seesaw of automatic alertness that goes all the way from panic, or it can be alertness, or that alert is that call. So there's a range, basically there's a continuum, be that you're in deep sleep, or to the other end of the seesaw is that you're in light sleep, or you're kind of sleepy, or you're just feeling kind of relaxed. You're going to have to map out a baby's schedule in order to make sure that they are getting changelings and nurserings, etc. at the appropriate time, and it's to try and maintain as if you can't sleep or you can't sleep continuously, to try and maintain your automatic nervous system in a place where you're not going into heightened states of alert when you'll ideally be sleeping. So this can be translated to try and stay calm when you're sleep deprived, which I know is really hard to do, but this is also where non-sleep deep breath protocols can surface again and can potentially helpful for people to be able to recover, not necessarily sleep, but for them to maintain a certain amount of autonomic regulation. So what this would look like as the baby goes down, maybe it's only going to be for like 45 minutes, but if you can capture sleep, then capture sleep. There has been data showing that what's called polyphasic sleep, so if you can sleep in 45-minute increments or batches, even if it's spread throughout the day in periods of wakefulness in between, as miserable it might sound, it's going to have, obviously especially around work cycles as well, it's going to help in terms of the total amount of sleep that you need. It's very hard to schedule this for most people and maintain that, but if you've got a baby, the baby may be throwing them into a kind of schedule anyway, so if you can get 45 minutes sleep whilst they're asleep, then that's great. If you can get another 45 minutes sleep after waking, and then they go back down again to sleep, then great. So as many phases of sleep that you can get, and if you can't sleep, the data on non-sleep depressed type protocols does show that, at least from a neurochemical level, And I want to be clear what that means is that the reset of things like dopamine levels in different parts of our body, those timings tend to reset themselves pretty well. If you can access these deep rest states, so that means not being alert through the entire time the baby's asleep, or trying to sort of mirror the baby's sleep cycle. This can be brutal for some people if you're trying to prepare meals and do all the things that recognise obviously all the other constraints of parenting. Not just obviously mapping out your baby's sleep cycle, but as they approach the ages of like 1, 2, and 3, and 4, that's when certainly the optics of the eye have improved, but you don't want to damage the eye still within that time with very bright light. So they're still much more sensitive even until they're like the ages of 10 or 11. So trying to get longer and longer batches of sleep through, hopefully obviously not by using anything like melatonin for children, but trying to get longer blocks of sleep that map onto these ultradian cycles, that we can be better off and get like a 2 or 3 hour, like 90-minute cycle, and then a 4th hour batch of sleep, because waking up in the middle of those ultradian cycles can be brutal for a parent and a kid. So if you want to get, so if you can't get a full 6 or 10, some kids can even be sleeping 12 hours when they're growing really quickly. Trying to get these batches of sleep, even if they're fractured through your 24-hour period, so that they kind of match into these 90-minute cycles. So maybe one ultradian cycle of 90 minutes, or 2 back to back, or 3, having these block cycles of being awake and being asleep. That's going to be better than waking up in the middle of an ultradian cycle. It's just going to get any number of these things in a better direction, so that when you were to say just stay in force or full force of 8 to 10 hours sleep. I mean, literature does show that some kids sleep great through the night, starting from a young age, and others don't. Typically, I hear that this is, people that are struggling tremendously. And understandably, they're not sleeping, their kids are not sleeping, or it's their kid that is sleeping in such brief periods. If you can't sleep to try and access sleep, or if you can sleep, even if it's fractured, when sleep is really, really dismantled in meaning, so it's happening in various times of day, that's especially at those times when it's going to be especially important for parents to get morning and evening sunlight, because your circadian clock is going to be in a tailspin, and basically it wants to anchor to something. So you want to give it 2 anchors of morning and evening light. So rather different to what I described for shift work, this is when things are really chaotic and you're just not able to sleep. Similar circumstances that can arise if you're not taking care, or taking care of a loved one, or you're up all night trying to stay calm using these NSDR principles and protocols. I know it's harder to do than say, but those protocols are there, they are free, and there's research to support them. So try and get sleep wherever you can, but also try to get morning sunlight and evening sunlight in your eyes if you can, and if you can't, then try and get some artificial light. So let's talk teenagers. They have a tendency to wake up later and go to sleep later, in part just because they're sleeping a lot more. They're churning out more gonadotropin releasing hormone and luteinizing hormone, because their bodies are at a change really, bodies are at a state of really changing, should I say. They're at the fastest rate of aging that any of us go through in puberty. And there's a huge number of biological processes that are happening as they go through this pubescent period. It is an accelerated period of aging, and the circadian clock mechanisms sometimes are very intact, and sometimes they're a little dismantled and going through some kind of change, but prioritise the duration of sleep for adolescents and teens. Now, if that means that they're sleeping till 2 p.m. and then waking up and then staying up all night, this can obviously become a problem, especially with like devices and texting in the room, playing games, video games. Morning and evening sunlight would be ideal, but some kids are just gonna sleep through the morning sunlight. However, if you were able to measure their temperature, what you would find is that their temperature minimum would come up later in the morning, and it's going to be like 8 a.m. It's going to be maybe then even 10 a.m. if they're sleeping till 11 or 12, or maybe 8 a.m. if they're sleeping until maybe 10. So remember, temperature minimum is, say, 2 hours before their average waking time. So ideally, you want them to try and get regular sunlight either in the morning and in the evening, or both. If they're sleeping through the morning sunrise, that's probably not as much of an issue, but waking them up and sleep depriving them is probably actually going to be worse at that point, because their temperature minimum is actually then going to be falling later, so their circadian dead zone is later. So with adolescents and teens, give them a little bit more rope in terms of allowing to have this leeway in just in their own schedule. I know that some schools are even starting classes later on the basis that some very good biology support that this late shifted rhythm is in an extended sleep phase, obviously during this age group. There has been studies showing that turning on lights in the room of a teen before they actually wake up does help them. It does get more sleep during the subsequent night, also tricks them into going to sleep a little bit earlier, but also gives them about 45 minutes more of deep sleep. And that's been shown statistically. Total sleep time increases as well. So if they're hiding under the covers, that's not going to work because their eyes actually have to be open. But some parents, I think, are putting even like flashlights over their children's eyelids before they wake up. But because of this, if lights are getting through to the eyelids and say it's 8 a.m. and the kids are still asleep, they're going to wake maybe at 10 a.m. You're giving them light. So just after or around their temperature minimum, which is going to make them want to go to sleep earlier. In the cases of teens, for some reason, we don't quite understand sleeping longer, around 45 minutes longer, in the deep sleep. But adults can do this too. So if you persuade someone to put your lights on a timer, say, for before you wake up, that's really going to help you actually wake earlier. So now let's consider the elderly. So there's a tendency to want to go to sleep very early and wake early for many, and evidence shows that melatonin levels and the pattern of melatonin secretion can become a little chaotic in elderly folks. So it's going to differ in terms of rates of aging. So you might see some 65-year-olds that are struggling to move, and then there's some 80-year-olds that are really just full of energy. There's a lot of variance and genetic variance as well with lifestyle factors. Certain lifestyle factors can play an important role in rates of aging. I think it's the most prominent results from sleep and circadian rhythms in the elderly. They need to get as much natural light, even if it's through windows. And I know that obviously some elderly people can't get outside, it might not be safe for them to do so, they can't move around very well. Or even easily exercise, but exercise can come in various forms to those that can't obviously get outside and get a ton of sunlight by jogging or cycling. Some of them are just not able to do that. So light through a window in this case, or an open window ideally for temperature reasons. Sometimes the window has to be closed, getting people near that window or away from artificial light early in the day and away from artificial light during the night can have a tremendous effect. And in elderly, that's when melatonin might be a viable option. So in most cases, people are in their 70s, 80s, maybe 90s, and they're not turning out a lot of gonadotropin, luteinizing hormone to begin with, and this is where struggles with falling asleep and staying awake might occur. All the same parameters that we've described before still apply in terms of light, exercise, temperature, but this is where for these people melatonin might actually have some great benefit. Also, having a regular schedule for folks that are elderly and getting as much natural light as safely possible are going to be really key in terms of levers for adjusting sleep and circadian cycles. So again, these NSDR protocols, viewing natural light and exercise, and also potentially looking at hot or cold baths and showers, or other behavioural protocols can help in this manner. So lastly, I just want to go on to if you are travelling and wanting extra bit of sleep or a bit of extra buffering, we can talk a little bit about supplements. So obviously supplements, I would always recommend that you speak to a health professional about firstly, but these are some that could help. So magnesium has been shown to increase the depth of sleep, and it also shown to decrease the rate and the amount of time that it takes to actually access sleep and fall asleep during various forms. The main one is magnesium threonate, which seems to be more bioavailable in terms of the forms of magnesium that's out there. And magnesium threonate, it seems it's shuttled preferentially to the brain, which is actually where we want it. And there's certain transporters that actually engage like GABA pathways, which I'm not going to talk about today. And it tends to turn off certain areas of the forebrain to actually allow you to sleep. Now, there are also things like magnesium glycinate, and these are similar to threonate in terms of the tissues that it's shuttled to. There's also magnesium malate, where ATP is preferentially shuttled to the muscle, and it appears to as opposed to the brain. So it's going to be more of a muscle repair type thing, is magnesium malate, rather than restoring magnesium in the periphery, rather than actually going to the brain. Magnesium citrate also does have some side effects to it for this one, so it does seem to have more of a laxative effect rather than a cognitive effect. So of all those there, magnesium threonate would be the one of preferential in terms of helping to actually turn down process and be able to fall asleep. And ideally between 100 to 300 milligrams has a calming effect. So another supplement that can be beneficial is theanine, and this actually thins certain pathways and involves being able to turn off top-down processing and thinking, making it easier to fall asleep. So again, the 100 to 300 milligrams has a calming effect, and it's actually showing up now in a number of different energy drinks and even some coffees as a way to get people to actually ingest more of a certain type of coffee because of it. The idea being that it would take away kind of like the jitters and the anxiety, allowing people to actually drink more coffee. So when I'm talking about this, I would say, with the magnesium and the theanine, is to take this like 30 to 60 minutes before bedtime, not during the day. But before bedtime, with or without food, generally doesn't make any difference. And a combination of these things can really help in terms of, getting to sleep. It can increase the intensity of your dreams, can give you very vivid dreams. So for people that might sleepwalk or people that might get up with night terrors, generally stay away from theanine, would be my advice. Magnesium threonine might be something to explore for those that don't have issues during the night with this. Next, there is something called apigenin, which is a derivative of another type of supplement, which is a little bit more hypnotic by activating certain chloride channels that make you essentially feel sleepy. So it can have like a sedative effect. But this can actually also have estrogenic effects. So if you want to keep your estrogen high, which obviously as females we do need estrogen, you might want to be cautious on apigenin. There are also things like 5-HTP. It's got an element to do with tryptophan. These can actually help you get into a deep sleep, but again, they don't necessarily help you stay in that state of deep sleep. And it can actually, because of the system that it works on, it kind of interferes with your serotonin system, and again, subsequently your dopamine system. So I find that if I increase my dopamine by taking something like L-tyrosine in a pill form, then you can actually kind of crash quite hard taking this 5-HTP or like some kind of L-tryptophan. And then lastly, acupuncture. I think that's lastly, we'll see. So the good appropriate use of acupuncture can actually stimulate some anti-inflammatory compounds when it's actually done properly, as well as certain parts of the body that have has an effect to increase your inflammation. So if you can go to someone that's good and knows these good sites of increasing or decreasing inflammation, that can be really, really useful. And with that, I appreciate that I've thrown a hell of a lot of information at you there. So the main thing I want you to try and figure out is that finding out your temperature minimum and start to work with that to access your sleep and wakeful cycles that you want to access more of, whether that's helping with the form of doing the NSDR protocols, maybe exploring supplementation with that if that's your thing. But now you have a lot better of an access to the mechanism about sleeping and wakefulness. So you know that your temperature minimum and understanding that light in the early part of your day is valuable light when you want to be awake, provided it's not damaging. It's also for you, great for you, whether or not comes from screens or bright lights, but sunlight is obviously better. Avoid light in the 4 to 6 hours before your temperature minimum, or else you're going to delay your clock, unless you're obviously travelling for that purpose, and that's okay to do. Use temperature increases to shift your clock, and decrease temperature to delay your clock. So mapping out your temperature and understanding that you don't have to know degree by degree through the day, but know your minimum and maximum during your 24-hour cycle. And you can then feel great and power through that, because you know that you also now know about these ultradian cycles, these 90-minute cycles, in which you can do focus work within, or you can obviously sleep within when you've got a baby. And don't expect the focus to come early and expect to come in the middle. It's going to then taper off a little bit. And we can also now look at shift workers and travel and people that are jet lagged, and even those that are at home using a lot of screens, that how this can actually affect our sleep-wake cycle. It does have a tremendous effect. Temperature minimums will allow you to shift your biology in the ways that you want to go, and will also allow you to shift your psychology in the ways that you want to go as well. So all from this is find your temperature minimum, that 90 minutes to 2 hours prior to you usually waking. If you usually wake at different times, take the average over that space of time of the space of days and use that. So I hope this has been useful. I realise it might all seem a bit I was kind of like trying to read through my notes as well, of trying to make sure that I was succinctly telling you everything that I needed to tell you. If you do have any questions, please do get in touch, and I can obviously go through and clarify any points in this that haven't come across clear enough. But yeah, thank you very much.